Welcome everybody to the session. This is the second joint Caltrans session, and this is on travel data collection approaches. And we're doing something really different, which is to talk about freight data collection and active travel data collection in the same seminar, the same session. So I'm from one to the other. I want to introduce our panelists. And somebody wave or just say hi or tell me, give us your title or things like that. Andreas Kraus from Caltrans.
Hello, everybody. I'm Andreas Kraus from Caltrans. I'm the statewide active transportation data manager, or at least I was up until this week when I took another job within Caltrans.
And I should add that is not at all unusual at Caltrans, right? So for all we know, you may end up in the freight data section.
I did not, but it's a good section to be in.
Okay. Scott Strelecki from SCAG.
Yeah, hi. Thank you very much. I am the supervisor for our goods movement business unit here at SCAG, so happy to be on the panel. Thank you.
And Susan Handy.
Hi, Susan.
In the room, I should add. All the way.
All the way. Not by bike.
Steve Ritchie.
Hi, everyone. Good to see everyone. I'm at ITS Irvine.
And Luciano.
Hello, everyone. Thank you for having me. I'm Luciano Rosera. I'm a computer scientist at Viterbi School of Engineering. I'm also the associate director of IMSC.
Okay, thank you, everybody. So as I said, we're going to talk about two very different types of data collection here today. With the focus on innovative ways. I don't have to tell any of you that we have all kinds of new opportunities for data collection that we in the transportation sector, I think, are just kind of getting our hands dirty, really thinking about what we can do. And so I think we're going to learn something today on where things are and where we can go with some of these opportunities. So I'm going to start with the active travel part, which means that Andreas is up first. And Caltrans, as it turns out, has a pretty elaborate active travel count program right now. And Andreas, if you could tell us a little bit about the purpose of the program and what's happening today, where you think it might be going.
Sure. Well, thanks everybody for inviting me to come speak. Just wanted to do a quick disclaimer before I get started that my comments are being provided in the spirit of information exchange and may not necessarily reflect the official views of Caltrans, the state of California, or the Federal Highway Administration. So with that, active transportation terminology, just active transportation means bicycles and pedestrians, more or less, same as micromobility or non-motorized. I might use some of those terms interchangeably, but we're talking about bicycles and pedestrians. So back in 2015, the state of California changed its strategic goals for transportation to include a much greater focus on walking, biking, and transit. And that was done in large part, for safety and also for climate change goals to try to get people out of their cars and things like that. So along with that came the recognition that we actually need more data to be able to manage for bicycles and pedestrians across the state. So last year, back in December 2021, Caltrans initiated a new program to start collecting bicycle and pedestrian count data or volume data to provide that information. So why do we need to count data? It supports a variety of needs. It supports planning and design of actual infrastructure projects to improve connectivity or improve safety. It helps prioritize our infrastructure dollars so we understand where to make various investments for the biggest bang for the buck. And it helps us evaluate both the projects that we build and the policies that we implement to try to promote more walking and biking and safety. It can feed travel demand models that help with that decision-making process, and it can also be used to calibrate the emerging field of the big data, transportation data analytics platforms. So count data is pretty valuable, and Caltrans has been collecting it for just over 100 years for cars and for vehicles. But we haven't systematically collected the count data for bicycles and pedestrians. Several of our program partners, different NPOs and such cities, they have initiated their own count programs over the last decade or so, and it's an emerging field, and more agencies are starting to collect this data, but there's no centralized or consolidated statewide effort, and so that's what we're trying to build here in Caltrans. So in that count program, it's, obviously it involves installing counters, but there's also policies and procedures that you need to develop, and databases to house the data, and partnerships that you need to develop to make all of this stuff work. Where we're at is we just got started about a year ago. I think we've got a good understanding of some of the issues and challenges in front of us. We're starting with doing some deployments of counters, and those deployments are going to start collecting the data, which we need, which is good. We're trying to focus on places where we're doing complete streets projects initially, and also an important part of those initial counters is for us as an agency to actually understand how to do this, because we haven't done it before. We don't have the policies and procedures in place, or the databases or anything like that. And that all has to be developed. And so starting to deploy counters is the way that we learn and figure out how much it takes and how much it costs to do all this stuff. The other part of the program that we've been starting to work on over the last year is the network design. So it's expensive to operate count stations. And when you scale that up to a statewide scale, it's very expensive. And so you have to be looking ahead to understand how many count stations you need statewide and how that information is going to plug into your various decision-making processes, and then run various statistical optimization routines to try to minimize the number of stations that you actually need to provide the data that you're looking for as a way of managing costs. So we're making some initial strides. We're doing some pilot efforts on the statistical network design pieces. We're starting to deploy some count stations as we have funding to do so. And that's kind of where we're at right now today. Some of the big challenges that we have, I'd say first and foremost, you want to collect the count data that you need. And so defining those needs, when we look at the needs, they're very diverse across Caltrans. So some groups are really focused on what's happening on the inside of an intersection. How many pedestrians are using that crosswalk? How many bicycles are turning left? That kind of stuff. Other groups are looking at corridor level type things. And so how many people are moving from one part of the city to the other part of the city, or across different corridors and things like that. If you're a travel demand modeler, you care about things at even larger spatial scales. And then there's the issue of where do you put these counters? Managing the state highway, Caltrans can put counters on the state highway, but we actually need information off of the state highway because the travelers are fluid. And so understanding the bicyclists that come from off the state highway and start using the facilities. So we need data across different geographic domains, depending on your interest. So getting all that stuff sorted out and actually being able to design a network to meet a very broad and diverse set of needs and of monitoring objectives and of geographic scales is a challenge. And then trying to do all that while balancing cost. So some of the innovations that we're bringing to the table is the statistical sampling design and optimization on the network. I think that's a newer piece that hasn't really been done in other parts of the country just yet. And there's a lot of new technologies that are out there. So video analytics and using cameras actually to conduct the counts I think that is the wave of the future. We're starting to move away from traditional in-pavement counters. And then also the big data analytics field, where count data is great. It gives you volumes, but we're starting to wanting to understand what's the origin and destination of those trips. What's the travel speed of those trips? What are the traveler demographics? These are things that you can get out of transportation big data platforms, which are tracking basically cell phone movements. But those platforms, they're okay calibrated for motorized vehicles because there's a lot of ground truth count data on cars and vehicles that they can use for calibration, but there's very little data on bicycle and pedestrians. So the big data platforms are largely uncalibrated at this point. But as we're starting to provide more data to them, then they'll be giving us a lot more information back than you can get just from pure counts. So I'll leave it there. Thank you very much.
Thanks, Andreas. That's a great starting point. We're now going to jump over to freight. We're going to keep doing this, so keep your brains alive here. So I think we're going to go to Scott next. For those of you who are not from Southern California, SCAG has been busy with a number of goods movement related data collection efforts. I'm familiar just because I've been working with this stuff. For example, a lot of effort trying to get some information on curbs and who's using the curb, for example. There's an awful lot of interest, of course, in our region for zero emission trucks, which means you actually need to know something about where trucks are and where they go. And it turns out that's not so simple, because even in this big data era, whatever GPS equipment that are on trucks are just usually proprietary, so you don't have access to it anyway. Scott, do you want to tell us something about what's happening in freight data collection, and in particular, the last mile, first mile activities related to the zero emission truck efforts?
Yeah, sure. Thank you very much for the opportunity, and happy to be here. And hopefully, we'll have some good insights. So I think a couple approach, or kind of two-part approach to this. So yeah, generally kind of like what's going on with freight data here at SCAG. So I think the easiest way to kind of orient everyone is, travel demand, obviously extremely important, right? Modeling, all the things that we need to do from a planning standpoint. But at the same time, we also recognize the extreme importance of kind of the land side, right? And the origin destination, generator, attractor component. So our approach that we've been working on a lot is we've been trying to dive into some of that deconstruction of the industrial environment, right? So we've put out an industrial warehouse study in the past, not too long ago, 2018. But at the same time, we've been internally kind of really working on how to dissect, these different industries and, interchanges and flows, et cetera. So I'll just give a real quick example. I mean, everyone's familiar with Amazon, right? We all order from Amazon. So, Amazon imports a lot of goods. They come into the ports of LA Long Beach. A lot of those are interchanged and consolidated in LA County as close as possible to the ports. And then, that's a 40-foot container, gets transloaded into a 53-foot truck. That truck goes to a fulfillment center. all the products, get organized on where they need to go. And then that then therefore goes to a delivery center. Once it's at the delivery center, that's where the vans start dispersing throughout the entire region and dropping goods off at businesses, at residences, et cetera. So that, Amazon is a great example of just domestic demand and consumption of how many points, things are switching and equipment, et cetera. So from our perspective, there's a lot of value you can gain in understanding how the equipment moves. What are the key relationships of the different facilities that relate to that? And then that starts giving you an opportunity to begin to think about placement of where optimal areas are, where you want to collect data, whether it could potentially be in corridors or whether you want to have information coming out of specific areas at the more local level of how it connects into corridors, et cetera. So that's just a little insight on kind of on the land side of how we really are viewing, that sort of thing. And then real quickly, I'll just touch on, there's a lot of different elements related to intermodal facilities and railroads, GPS with trucks. I think that's been mentioned. That's kind of a tough area to get at sometimes. Last mile curb elements, e-commerce data. We coordinate a lot with the ports, really try to touch base with operators as much as we can when we do studies. We've worked with BNSF, Union Pacific in the past. Getting primary data is always the most valuable from the operator. Sometimes you can get it, sometimes you can't. And already like Andreas mentioned, big data platforms, right? It's the same type of thing going on the freight side. And then specifically to kind of dive into the zero emission work that we're doing, we have a study that we've just recently kicked off that's focusing on a roadmap to understand heavy and medium duty zero emission infrastructure needs. That's just starting, and that's going to try to, as I said, lay out the roadmap of what do we need for the region and what does that look like, as well as getting into maybe some test areas. But the study we currently have going on is our last mile freight program. And that is a program that we've partnered with the MSRC on. And it's a part of the Air Quality Management District. And essentially what we're doing is we are working directly, SCAG as the overseeing the effort through MOUs with private companies. So, we've got small independent owner operators, 1 to 10 trucks. We're working with, Cisco, the largest food service company in the world, Pepsi, we've got a lot of medium-sized businesses, et cetera. So we have contracts established with these companies where we are requiring them as they transition, they build zero emission infrastructure, they acquire and procure the zero emission battery electric vehicle trucks, and begin to operate them. Obviously, our goal here is focused on air quality, emission reduction, all that sort of stuff to benefit public health and environment. But so as part of the MOU, we're collecting 6 months of data. We're comparing the old technology, primarily diesel equipment, with the new zero emission technology, and obviously looking to ensure that as we get public benefits, what is the ability for scalability based on the return on investment and the needs of each of these different businesses, right, as they operate. And I think that, obviously this is innovative in that the state obviously has a lot of experience in working with companies and doing this sort of thing. But for us, as an MPO, this is a great opportunity to bring this a lot more down to the local level, and work with our member agencies, and also make sure that there's a lot of marketing and really getting this out to local communities so everyone can start seeing, how this works, what are the benefits, all that sort of stuff. Challenges, as everyone knows, the supply chains have been disrupted. There's a lot of impacts to lead times. Everyone kind of talks about government bureaucracy, right? Well, working with these companies, sometimes it takes them longer to go through their internal process as entering into contractual relationships. So I would say that, that's definitely been a challenge for them to kind of work with us. And then the time it takes to go back and forth and negotiating some of these MOUs. But ultimately, I think the biggest win out of all this is, we are weekly engaged with industry, and, that's invaluable with how our team learns and how we grow and how we kind of collaborate with industry. And then that helps us also with all our partner agencies and information sharing collaboration further. So I'll go ahead and stop there. Thank you.
Thanks, Scott. I'm going to turn to a different, more technology-oriented piece of the freight data collection puzzle, and that's what Steve Ritchie's group has been doing in terms of what he's calling the Freight Mobility Living Laboratory, FML2, something like that, for the advanced detection of truck flow. So this is taking sensors to the next step, if I'm recalling correctly. So Steve, tell us what you're doing in terms of these new technologies and how they're working out. I know you have some test cases out there already.
Right. Thanks, Jen. Thanks for allowing me to participate today and share some of our work. I was going to begin by saying, and you've stolen a little bit of the thunder, and so has Scott, in terms of the persistent lack of publicly available data in the freight area, which is really motivating a lot of what we do. I mean, as has been said, there's a general unwillingness to share data. A lot of it is private, proprietary, and the observable data that we're commonly able to collect involves things like truck counts, but they're often so limited spatially and temporally, and so unreliable and outdated as to not be useful. And for example, I think it's true to say that Caltrans and CARB have little accurate idea of current, let alone real-time heavy-duty truck utilization of the state highway network. So for us as engineers and planners to assess the success and impacts of policy changes, infrastructure investments, we need to be able to measure system outputs of interest. And these, of course, include truck flows, among other things, on the network. And this is especially true as we transition to zero-emission heavy-duty trucks, especially in the drayage sector. So the Freight Mobility Living Laboratory, or FML2 as we've come to call it, is for us kind of the next generation of our research, developing the truck activity monitoring system, which is the result of many years of research really for Caltrans and CARB. FML2 is what we like to call an open innovation ecosystem. It allows us to explore field deployment of innovative technologies for freight data collection. It's a real-time scalable system, provides a whole range of data, including things like tractor trailer body types. There's some 40 or so different classes that these vehicles, the tractor and the trailer, can be classified by. Provides axle classes. These are the traditional sort of measures that agencies have used, gross vehicle weight class. And of course, truck counts, speeds, and weights. Also more recently, trajectories within the field of view of the sensors. And this is all coming from a combination of sensors, traditional pavement inductive loops, weigh and motion station data, automated license plate recognition, cameras, and LiDAR sensors. So these kinds of data are used for pretty broad spectrum of needs: pavement design, freight planning and policy, freight system management operations. Helps with federal reporting requirements that the state has, including supporting the return of highway trust funds to California, and of course things like environmental analysis and environmental justice concerns because of the freight externalities. So I mentioned LiDAR, maybe the most innovative aspect of what we're doing recently. LiDAR stands for light detection and ranging, and it can generate 3D images of objects. So unlike the applications of LiDAR in autonomous vehicles, we're looking at stationary roadside LiDAR as opposed to mobile LiDAR. And this is assisting in estimating things like, the traditional traffic state parameters like volume, speed, even acceleration and occupancy. So we hope that this could ultimately replace inductive loop detectors, which are in the pavement. In addition, when we're successful at getting trajectories, which is research underway, but showing a lot of promise, it can assist with detecting impaired driving and with license plate recognition, which basically involves us providing the license plates to CARB that has access to the DMV data. It can look up engine types and emissions, characteristics of the engines. It can assist with emissions estimation and also anonymous tracking of trucks through the network. So if I've got a moment, I'm going to try to share my screen. We'll see if this works or not. Let me just mention that we've got 126 sites across California currently. There was a reduction during COVID. There was a lapse in the contract for basically the internet connection to the site. So we've got 36 that are currently active. They're mostly in Southern California. 10 of them have ALPR. 4 of them have LiDAR. We're adding new sites near the Port of Long Beach and LA, and in the Central Valley. Caltrans District 8 is adding 80 new sites in the Inland Empire, the big logistics center in the Inland Empire. And we're also adding rail freight locomotive detection for CARB to FML2 in the coming months. So I think I've taken up more than my time. I should probably stop there.
Thank you, Steve. We're doing this in kind of actually a very logical order, because one way to increase data collection, of course, is to add more sensors, right, to be able to collect more. Another way of doing things is to figure out what you can do with sparse data. That is to say, given that you're never going to have a whole lot of data, how do you use what you can to infer as much information as possible? And that's what the group that Luciano is leading has been working on. And in this particular case, using vision detection along with other tools to try to figure out our ultimate wish here is to be able to generate an OD matrix of where trucks come and go from all of this passive data. So, Luciano, it is your turn to talk about that.
Thank you for the introduction, Professor Giuliano, and thank you for having me today. So I'd like to give a little bit of a background of why we got involved into this. So the IMSC is a center at USC that had a contract with Metro since 2012, and what we've been doing there is collecting data from essentially single loop detectors that provide count and occupancy on the roadways, including arterial and highways for Los Angeles County. And we make that data obviously available to Metro. Now, when it comes to looking at those types of sensors in the context of being able to account for the trucks that are on the roadways, it turns out that they're not, in terms of resolution, good enough. Meaning that they will detect a truck, but you can't really understand what is the class of the truck. And if you look at the Federal Highway Administration number of classes there, that if by memory, if I remember well, it's 13. You need to have a good understanding of what classes of trucks are out there, because they obviously impact in various ways the roadways, both in terms of pollution for the fleet that is mostly going about these days, but also for understanding how do you transition to zero emission trucks, and also understand obviously pollution and mitigate traffic and so on. So that means that what is really needed is a way to acquire data that is fine-grained, both at the temporal scale and also at the spatial scale, so that you can evaluate the impact on the communities. So one of the metric that has been used is the origin destination matrix that basically tells you where the trucks are coming and where they're going, and that is basically generated mostly based on traditional sources such as surveys and some of the sensor data, but really not much that gives you the ability to understand what is the traffic down to, say, hours or a day type of level. That is really what is important in terms of being able to make data-driven decision making. So what we've proposed and worked on is to try to leverage all the sources of sensor data that are available on an area that is most impacted by truck traffic, and that is the area down by the ports of LA and Long Beach. And so there, to give you an idea of what is today available in terms of sensors, we have about 5 waiting stations for trucks that will provide you with very accurate truck information. UCI has a project where they use double loop detectors that is very good at classifying truck types, and that accounts for 6 other locations. Then we have obviously RFIDs that are available at the ports, and another source that is closed circuit surveillance cameras, basically, and those amount to 15. Now, the totality of that obviously is for such an area is not enough to be able to get down to the spatial resolution and temporal resolution that you may want to have. So what we're working on is both trying to understand what would be a setup where you would get to a given resolution map for all the matrix that enables us to make a good decision in terms of planning, and also trying to understand how to integrate this information, so all the sensor observations, in a way that we can estimate all the matrix, not just where the sensors are located, but at the origin and destinations and on the road network. And so we've been working on that primarily with the CCTV cameras, so that we have used to detect truck flow. There we've used data that we got from Caltrans cameras that are webcams that are publicly available. And we repurposed technology that is geared at detecting and tracking objects to detect and count and classify the type of trucks that are seen by those sensors. So we were successful in doing that. And we have also developed algorithm to estimate from those cameras information, the OD matrices that we produce. The next steps obviously are going to be in terms of understanding what that are the limitations of these sensors, and maybe I can talk to that later. And how do you scale those types of systems to provide a granularity that is probably best computed in a way where you have higher resolution in terms of the flow information for area that matter the most, and use less in other areas.
Thank you. So we've talked about kind of several levels of data. Back in the old days, we could go out and count things, and the survey was kind of the basic thing to do. And in travel behavior, it's been travel diary surveys and things like that. And on the truck side, it's been laborious surveys trying to get truckers to answer questions about where they went, right? These are really expensive things. And I think the fact that NHTS is making these huge changes that Susan probably knows a lot more about than I do, is a signal that travel surveys are going to be different if they continue, if they're going to continue to exist, they're going to be different. And so that's kind of one level. And then the next level is all the technology that we've been talking about. So you can use technology. And then the third level is what Luciano is doing with, you've got very limited data. What you do is you mix and match and you try to figure it out. So I think I want to start with Susan to talk about on the travel behavior side, and in particular the non-motorized side. We've got this big effort on the part of Caltrans, that a statewide counting. What do you think? Where is it going to go? What are your suggestions? And how does all this kind of relate to our conventional travel survey world?
Well, I'm definitely the token low-tech person on this panel. The point I want to make is that we need all of this kind of innovation and Caltrans counting program, but it's, in my opinion, not going to fully replace the old-fashioned ways of doing things, surveys in particular. That to understand everything we need to understand, at some point you've got to talk to people in some way. So count program, really excited about that. I think that's fabulous. And as Andreas said, part of the innovation there is just figuring out how to deploy that, because we've got a whole big area to deal with and we've got so little sort of counting infrastructure out there. So counting really important for just knowing how much walking and biking there is and where it is. But as Andreas said, we also want to know where people are going, the ODs, origins, destinations. So we have some new options there, like a lot of researchers are looking at Strava data, which is a recreational sort of app. And that, that tells us something, but we've got issues about the representativeness of that sample. There's data like streetlight data that, comes from smartphones and is collecting data about all kinds of modes. But there are issues with that as well, because as Andreas said, the sample sizes are so small for biking and walking. We did a little study in Yosemite Valley looking at the streetlight data there. And that was very interesting because of the canyons, the smartphone, the signal thing was a problem in some places. So they have these little blackout areas in the data. But very small sample size. So they, I think we got pretty good data about flows, but not about counts, right? And they're doing some kind of interpolation that they don't explain to us. If we do have more counts, as Andreas said, I think you were referring to this, these companies will be able to do a better job of that kind of interpolation, because they'll have counts they can add to the data that they have. But, even that is showing where people are going, but it's not telling us who is biking, why they're biking, and what's their experience with biking. Video, I think, is an interesting idea. You could do something with video, I think, to get a better sense of who is biking, but you'd be making a lot of assumptions when you're doing that. So really, I think, there's no way around doing some form of survey if we really want to understand who is biking and why, and what their experience is. And also who is not biking, because that's really who we need to understand if we're going to try and get more people walking and biking, is who is not and why are they not. So yeah, innovation to be done on surveys as well. We just finished a really complicated effort that involved, we used RSG's RMoves app, which, tracks people with smartphones, but then there's also a survey component to it, so that for each trip, they report data about what was the purpose of the trip and who they're with, and the usual sort of stuff we collect in a travel diary survey. But people weren't always very good about filling out those surveys. So it still depends on people cooperating. And then we were working with the micro-mobility companies, and they actually did a lot of the recruiting for us because we wanted to focus on micro-mobility users. And they're going to give us some of their data about the trips that these people made. They're not going to, that was really hard to get that all set up, and they're never going to tell you who the people are or anything about that. So yeah, so we still need surveys, and I think there will be innovation in how we do that, but they're still fundamentally surveys, and we need people to tell us things. Just one other point I wanted to make is on the active transportation side, it's not just about the travel behavior, it's also about the infrastructure. So your student, Laura Messier, was talking about the sidewalk study.
She's in Dornside. Yeah, she's in Dornside, but she is doing the sidewalk.
Oh, okay,
Yeah.
okay. Yeah, just the fact that we don't have very good databases about bicycle and pedestrian infrastructure. Apparently, LA doesn't know if it has 9,000 or 11,000 miles of sidewalks. And then the condition of the sidewalk. So there is some interesting work. I'm not following this too closely, but again, kind of using technology and remote sensing sort of techniques to build up that database, because it's hard to understand what walking and biking. Know something more about the infrastructure that we're expecting people to use. At Georgia Tech, we have partners at Georgia Tech who I think developed a little robot to go down the sidewalks and collect data about bumps and bits. So anyway, I think there's some interesting work and innovation going on in building up that infrastructure. But we still got to talk to people.
In thinking about this, do you have any ideas about how we do surveys more efficiently in this world of nobody wanting to talk to you anyway?
Yeah. It's teaching a survey methods workshop this quarter that we just finished up. Students kept saying, oh, I'm going to assume a 30% response rate or 20% response rate. No, they're a little more conservative than that. Try 5% for a general population survey. I don't know. I don't have the answer. There are these Qualtrics panels that a lot of researchers are using, which makes it really quick and easy and not even that expensive to do a survey, but again, representativeness samples.
Because they're volunteers.
Yeah. Or they get paid, but yeah.
Yeah. So it's a selective survey to begin with. So now let's talk about, I want to kind of open it up now because people might have something to say about this other than our panelists. But I want to open it up, just some of these ideas about, you know, on the travel behavior side, it's really important to know who is doing it. On the freight side, the who is usually the firm. We need less information, I think, about the firm, you know. We don't have to really ask a lot about motivations because firms are profit maximizing. They're already doing whatever is the most efficient thing to do, whereas that's not what we can say about people. So, and, you know, in terms of these kind of very different things, what are the thoughts on, are we missing something? Is there some data collection here that we should be thinking about that we haven't talked about? Or, you know, what do we do in terms of improving our data collection methods? And it's almost funny to talk about how to collect data when we have washes of data coming over us, right? Like you said, nobody knows anything about sidewalks, but yet LA has online every single parking meter. Okay, so you can get that online. You can't get where the sidewalk is. So I'm thinking, and just would like to hear some thoughts about where can we go with this and improve what we're doing. What are the challenges? I know, Ed, at least somebody in your group was proposing data collection on a bicycle.
Yeah. We were looking at that. He actually left our group. June was gone on the bigger bit of things, but he was looking at what he had been doing was collecting pavement data based upon accelerometer responded to a bicycle. And the next step was looking at how we can get an idea of how deficient, and I guess I'll phrase it that way, how deficient our infrastructure is for folks with disabilities that are attempting to navigate through that. And we had our proposal last year funded. The idea was to somehow develop a mechanism where the data we would collect would be more reflective of what might impact someone in a mobility device. So we'll propose it again, I'm sure.
Andreas, can I go back to you for a minute? What I was hearing sounded to me like how we would go about developing the count system for the highway system. That we would try to find some sort of representative sample, and that's kind of how way back, God knows when, how many decades ago, we figured out all the counters for the state of California that we used to report to FHWA and everybody else. Could you talk a little bit more about kind of the network you have in mind?
That's a really difficult question to answer, actually. So anytime you want to go collect data, any monitoring program, the first question you should ask is, how are you going to use the data? And why do you want the data? Because understanding the answers to those questions drives where you collect it, how you collect it. And if you don't collect it in the right way, in the right place, at the right time, the best intentioned monitoring program will fail to provide data that's statistically significant or can be used for its end purposes. And so one of the questions we're really struggling with right now is, where does this data need to be collected? And the answer to that question varies depending on who you talk to, even within just Caltrans. And so, Caltrans does a lot of different things. And so folks over in the safety group they really care about intersections on the state highway, for instance, because there's a lot of turning movement conflicts, and that's where a lot of collisions with pedestrians and bicyclists happen. But we also have a rail and mass transit group, and they care about first and last mile issues around transit stations, which are primarily off of the state highway. Some of them are on the state highway. And you talk to our planning folks, and they are really interested in developing better bicycle and pedestrian facilities on the state highway. But to do that, they actually need to know, they want information on like a 2.5 mile buffer around the state highway where bicycles and pedestrians are allowed, so that they can best plan for routes and volumes that might be expected and understand where highest mode shift potential is to get people out of their cars and things like that. And so what is the road network that we're trying to monitor? And so that is one of the big questions that is unanswered at this point. So if we just look at the state highway itself, the state highway represents 5 or 10% of all the road miles in the state. If you put a 2.5 mile buffer around the state highway on those segments where bicycles and pedestrians are allowed to use it, all of a sudden we're talking about just over 50% of all of the roads in the state. Similar numbers, if you put a 1 mile buffer around all the transit stops, it's about 45% of all the roads in the state. And if you want to do both of those things together, you're looking at about 70% of all the roads in the state. So really, that's a lot of ground to cover with a monitoring program. And so decisions are going to need to be made in terms of what's the right geographic scope to actually try to cover. And then how do you actually mobilize an effort to pay for it and go collect the data, especially with different jurisdictions on who can collect data where and who owns different facilities and where can you put stations and things like that. So you have to have clarity on your objectives, which is going to give you clarity on your geographic scope. And then you need to do that statistical analysis on your network design so that you understand, do I need a station every half mile or every 10 miles? Or, how much information can I actually extract out of this station or this network of stations? Because half of the power of your data comes in how you design that network, not just the station that you're collecting data at, but how you've distributed those stations across the landscape.
So I have 2 questions for you, and then I'll maybe open it up. One is kind of a governance question. It seems like this is something for which local partners would be really critical.
Yeah.
And because they're going to have a much better idea of what's going on at the local level than Caltrans would have. So that's kind of question number 1. Do you have local partners? And the second question is, have you thought about either the sort of clustering sampling approach or a piloting approach where you might be able to work out some of these things at a smaller scale?
So it's still early days for our program. And I was the only full-time staff, so there's only so much we can do. We have identified the need for partnering. And that's not just for understanding. We need to be working with our partners to better understand the overall objectives and the need for the data to understand where we even want to place counters. And then obviously, once we get around to trying to design a network, then you're going to need to be working with your partners on the data collection side as well. So yes, partners are going to be really important in this process. We haven't reached outside of Caltrans in any kind of formal way just yet, but I would imagine that's coming in the next year or 2. And your second question, remind me? What have we done? On the network design side, we have 2 pilot efforts. We've picked a rural district, District 1 in far northern California, and an urban district, District 12, which is Orange County. and then we're working with UC Berkeley to bring in, to try to design and develop some statistical methods to even begin to understand how you would approach the network design piece. And we picked these two districts because they provide significant contrast, not only different geographical and climate settings, but very different transportation networks, different transportation needs, different populations, different issues, different management needs. And so we did that on purpose to try to get as much contrast as we can in these two pilots. And hopefully, if something useful comes out of those pilots, then we can take that and expand it statewide to develop the network design for the statewide.
Let's talk, I'm going to just open it up for a minute, kind of staying on the travel behavior side for a few minutes. Anybody have questions, comments?
Good ideas?
Not a good idea, but I know that City of Philadelphia, like they have, they collect monthly pedestrian data onto like certain districts. Actually, I was looking for it and they deployed like 23 cameras that measures like test volume for 24 hours a day. And they create this report like every month. So I think there's like, it's been there for like more than 2 years now. So maybe it's a good, thing to look at because they have like a specific locations they're looking at, but still it can give an insight to like where we should be taking more look at. And it's a good example, I guess. I don't know too much about it, but just a thought.
That's interesting. So in the urban, in the central core?
Yeah, it's a center district of the city of Philadelphia.
Okay. And the city's doing it.
Mm-hmm.
Interesting.
Yeah, so it says like they are not working as like a security cameras, but they just like take a look at the people through the camera, and they do not store like any specific images, but they just dump it. But they classify like whether it's more like I don't know like how they did it, but according to their report, like there's a section comparing the number of visitors, like categorizing them to residents and non-residents and like just visitors. So it's pretty cool how they do it. So it could be a way of approaching this data issue.
So maybe we could do fewer surveys and use other data. I don't know.
Yes.
I was just curious if anyone's heard of like productive relationships between folks like SafeGraph and Streetlight and public agencies, because we at UCLA have been working with some Streetlight data and find major issues. We're certainly not for bike ped work and transit, but even with some of the vehicle data, some big gaps and some big clear issues. And then when we ask them, they say, "Oh, well, we calibrated it. It looks good." And we're like, okay, great. Of course, they're not going to let us look under the hood. And then we're going through a client. I think Skag got us that accident, which was great. But yeah, I guess just any ideas about having more transparency, or Caltrans is thinking about. You were saying kind of ground truthing. If there's, are they going to give you anything in return, or are you just going to help improve their?
You're really at what I think is a really big deal. And that is the black box that you mentioned, Susan. The black box really has its problems when we are trying to actually use the data. Never mind the price sometimes of trying to get access to the data. We found amazing problems with SafeGraph data and start looking at it as well. And I don't know the answer, but I don't know from any of the public agencies. Yeah, I see a hand up. There's an answer.
Well, so one component, the count program that ideally we would be developing statewide for bikes and peds would actually have two separate components to it. One would be a network of permanent and continuous count stations to collect long-term count data. So we understand trends over time and variability and all that kind of stuff, and use that's the count network that I was talking about. But equally important is a separate count program that's specifically targeted at developing uncertainty estimates for big data platforms. And that count program would most likely look like a randomized sampling where you go out and collect data for a week or a month at a bunch of different locations where you have access to big data platforms. And then you compare those to the big data estimates. And then you can say for this particular year, the street light or the replica or the, big data platform X, their estimates are so good or they're not so good. And I take a long-term view with this. So more and more location-based data is becoming available every day for the big data platforms to use. As we start to provide more count data at the permanent count sites, that's also going to, over time, going to improve their ability to make estimates on volumes and travel destinations, things like that. But then if we add this third component, basically the validation of big data estimate component to it, now it's clear to everybody, regardless of the black box method they used, how good is it really for these different modes? And you can see, and then you'll be able to start tracking that over time. So it's an independent third party, essentially, validation of the big data estimates. And if they're seeing that on a statewide basis, then they're going to be pretty motivated to make improvements.
I think this question about then this public effort is helping them to improve their product that they can then will become more valuable, that they can sell for more money.
And not,
as opposed to you working a deal with them that you're doing all this counting, there should be public access, better public access to the data.
Actually, there was some debate in Korea. So there's like a Ministry of Transportation which deals with those new mobility services. And then they were asking these private companies to share their data, and then they will be, give it a public access to these data. And in exchange, there's going to be more projects for these companies, but still, it didn't really work out because those companies said there's issue with it, privacy issue, and then all that things. And then we are still debating on that, but it's pretty, Korean government is trying to push them to give public access to those data. Yeah, e-scooters and also some bike shares, in case of Seoul, they release the bike share data I think it's twice a year, so 6-month basis. So it gives counts of data where they're from, but they also have a separate data on the user characteristics and stuff. But you cannot combine them to see the user characteristics into those trips. But it's pretty cool to push it in that way, giving them some incentives to give access to their data, and then in exchange, they give access for research and more policy development.
So let's go back to freight. Now that we haven't solved the person problem, we can go back to freight. Where are the opportunities in freight? Now, I'm just opening it up. Steve, Scott, Luciano, anybody in the room? What do you see as some of the opportunities that we should be exploring?
That's a really complex question you just posed, right? As I'm sure you know. The freight is so complex compared even with passenger transportation. What we can observe, especially in terms of truck flows, let alone commodities, is really just part of a larger complex supply chain, right? You mentioned earlier, I guess, about decision makers, but we typically don't have one readily identifiable and accessible decision maker we can survey who's choosing things like domestic ground modes and destinations and transshipment points and routes and timing and so on. Is it the beneficial cargo owner, is it shipper carrier, 3PL, 4PL, and there's all sorts of complexities associated with private sector issues having to do with production schedules, contracts when long-term contracts may result in what we observe to be suboptimal. We think it's suboptimal, but in the bigger picture, could be optimal for the beneficial cargo owner. And I think there's an issue about whether something like utility maximization of an individual entity, as we tend to do in the passenger field, is that even relevant in terms of freight? So in terms of demand modeling, there's, I think, one really major issue, and that is that we have a lack of estimable theoretical constructs for development of policy-sensitive models. I mean, we've tried to use passenger transportation process like the four-step UTP process. Most of those models have been truck-based over time as opposed to commodity-based, but the newer models are commodity-based models. I mean, we helped develop the California statewide freight forecasting model that California is using now, and that's great, but it's based on FAF data, freight analysis framework data at the federal level, which has all sorts of issues too. So, I think the models, the data collection that we've done has pretty clear uses, but Andreas really hit the nail on the head earlier. The data you collect and the gaps really depend on what you need and what the data are for. And that really needs to be articulated because there's so many different uses for it. And the data we're collecting has some very specific uses, but in terms of travel demand modeling, the demand side is really poorly represented still in the freight sector. I'm not sure I really answered that. I'm sorry, I rambled a bit. But,
you just identified another really big problem in freight research.
Yeah.
That is definitely trying to model something that is so complex. And, one of the things I've learned from working with computer science is that another way to look at the world is to be able to predict, not to worry so much about the underlying relationships, right? Which is what we worry about, but the ability to predict. So if we really want to predict truck traffic on the network, what do we need? And, is it sufficient to take that approach?
You're asking me?
No, I'm waiting for Luciano to chime in here.
Oh.
As the computer scientist in the room.
Right. So, you're right. As computer science, we tend to get hung up a little bit too much in the details, but I think the big picture is really what the ability to collect data at a fine resolution will let you do in the future. And for the moment, we are basically at the point where we cannot really make informed decision about policy that can have a real impact, and also evaluate what that impact is going to be, because we don't have that data. So if we can get to the point where maybe it's going to be about focusing on a particular area where we know that there is a need. If we can get to the point where we can estimate how much information is needed to be able to start making predictions and assessment on what eventual policy decisions are made, right? So, and that basically means being able to simulate the impact of the policies and see in a short or longer term what the implications are. And to me, that's the capability there, technology-wise, is definitely possible. You're seeing with AI that in all in a lot of fields, people are using successfully those type of approaches to make predictions. So here what we need is maybe to be able to get the data in the first place.
So we're back to the data.
It's a chicken and egg problem, right?
Well, Jen, when you talk about prediction, at least as engineers, we focus on causality, right? We spend an awful lot of time trying to find causality.
I said we social scientists also worry about causality.
Yeah.
And so for us, the idea of developing a model, right? The true kind of throw all the data science kind of a lot of the big data approach is you can find the relationships in the data and you can use them to predict. And that's the objective. Our objective is different as a social scientist. You're absolutely right. But as we're talking about data, the thing we haven't really talked about directly is the privacy issue. And that's one of the things, right, that we're all, it's another aspect to deal with. On the firm side, it's about proprietary data and competitiveness. And on the person side, it's privacy of my own personal data. So have we, do we have any ideas about how we can address that? How can you think about ways that either you can use data that's truly anonymous or that you can guarantee anonymity. You can scrub to create anonymity. Are there some options out there that could overcome some of the privacy problems that we have?
I can try to give a quick introduction to that. So it's here what we're talking about is different types of data. So depending on what data you're looking at, I think that there are different approaches. So if we're talking about visual data, such as video that might be from surveillance cameras, there I think that what has been done in the area of surveillance is directly applicable, and it's mature enough. So you can do things such as edge computing, where you either pre-process the data that you're going to eventually ship and store to take out the private information. So typically, if you're worried about recognizing people, you would blur the faces of people, or you just extract a count of people and or trucks, and that's what you end up storing. For the data that is coming from private companies, there I think it's a little bit more complicated, because we're talking about GPS traces, and how can we incentivize them to share those type of data. So that there are, and there are also some things that people are doing. For instance, at the level of the query, after you have stored the data, you can make sure that whenever you issue a query on the data, the identity, say, of the person or property that you're querying cannot be revealed, and that there are different approaches that people use to that. So so I think that there is technology out there. It seems a little bit to be a kind of data-oriented approaches that you will need to consider.
Yeah, I was just kind of thinking of you. you created these, you managed these MOUs with operators, right? To collect data for a period of time. Can you tell us anything about the privacy side of that? Are you going to be able to freely use the data or make it public or anything?
Yeah, I mean, we've, when we developed the kind of the data side, I mean, it's a lot of question related information. There is origin destination request at the zip code level, and we haven't had anyone really strongly push back on that. I think, Penske, they kind of have been a little tough on talking about maybe some of that geographic information, but companies like Cisco and Pepsi, they haven't really pushed back on that. So, there's a very small sample, right? We've got like 7 companies, 18 independent owner operators, all that sort of stuff. But collectively, for this 6-month collection of, VMT, OD, that sort of stuff, for the most part, everyone is okay. And, from our perspective, what we're always sensitive to as an agency is kind of like talking holistically, right? Like, I think it would be out of line for us to start talking about any specific company and divulging stuff. But, if we aggregate it and talk about it, right, I think that's kind of the angle and the approach that we're looking into. I mean, it's the same thing with facilities, right? I mean, we know where every Amazon facility is, right? Walmart, Target, Home Depot, all these companies, we know where all their facilities are. We understand the supply chain kind of connections of how goods flow across them. But, we can't talk about that, right? We have to couch it by next code, industry code, or like maybe different transportation services that are provided within trucking or, different industries, that sort of thing. So, but we haven't, I don't know, we haven't had pushback, but we didn't ask them for like their literal, operating system of how their routes are and stuff like that, right? We tried to find the middle ground, and we felt like OD across zip codes was something that would be helpful for us and the public in general versus, going further and trying to get more into their kind of like, the GPS aspect of how they're operating.
So that's, you're making an important point because you've only asked about zip code, which are big geographic areas. So, that's one level, but getting the XY coordinate is another. And I see Steve's hand is up.
Well, I've got a question for Scott, actually, to follow up on what you asked. Scott, in executing those MOUs with the private entities, I mean, it would seem to me that getting them to share data would be based on trust and self-interest. And I'm wondering if you found that was the case, or was there also a more societal perspective that came to play, or not at that point yet, or perhaps ever?
Well, I mean, I think there's a couple points maybe to make. So one is this is a program where we're partnered with money, right? And there's a connection where they're having to put skin in the game with their cash of their business to get the new technology to build infrastructure, right? But we are through the program awarding them money as a part of that process. So there is that's incentive, right? I mean, once there's money at the table, I think anyone gets motivated. And then two, we do a ton of studies. I think a lot of people are aware. And every time we do studies, we organize it with our stakeholders of community, industry. We try to get academic, institutions. We try to bring everyone to the table as a part of the process. So I think with this program, we do have a little leverage now where we have established very strong connections. I mean, we had we had $17 million in award money. And I mean, we had like, $100 million in project proposal, right? So, I mean, we have a running list of like 50, 100 contacts now and companies and stuff. So this is what I think is the value out of it, right? Like for us to establish relationships and to build successful projects as partners with industry, that gives us, I think, a little more down the line, we can maintain those relationships. And with the Olympics, the FIFA World Cup and the Olympics coming to the city of Los Angeles, we want to talk to Cisco about how do we plan for that and how do you do food service delivery. We want to talk to these companies and have them on the books as we do further study and try to prep for some of these other things that are going to be coming down the line. So that's kind of the relationship, in my opinion, is huge. And sorry, the last point I think I would make is, I hear everyone talking about the demand side. It's extremely challenging, right? If we got excellent demand data, you could start building submodels and doing all these crazy cool things. But that's why we've really been focusing a lot on the facility side recently and trying to make these connections and to understand capacity. Like, we have the system and the network, but if we understand the capacity at the distribution, the logistics, like, the beneficial cargo owners, the shippers, the drivers, and we recognize what's happening nationally relative, like, how much square footage is Amazon growing in the Gulf and the East Coast versus Southern California, and we start piecing these things, that sets us up well to start kind of piecing the puzzle of, we need to talk to these certain companies in these industries. We need to make the connections on the logistics side here to inform maybe how we start looking at different approaches to surveying, and then all the technical demand stuff, right? I mean, I'm not strongly versed in that, but it's kind of like, I don't think there's just one solution, right? Like, we got to come up with the best pieces that we can put together. And at some point, you just got to start making some of these assumptions to refine the modeling. And, I think it's kind of a give and take. Like, if we can build this strong expertise, we can start then working with our modeling technical team and kind of putting it together, right? With what we have, or who are the right vendors, who are the best data sources. So, yeah.
Right. Great. Thank you very much.
So that brings me up to another question when it comes to freight data. And that is that the freight sector changes really fast. If I were sitting here 5 years ago, I would not have said that we're going to have this extreme demand for in-city warehousing that we're seeing, just for example. And that's shifting freight demand as we speak. So there's another kind of side of this, and people's travel behavior is changing really fast. You and I had the really quick conversation about e-bikes this morning. Things are changing really fast. What do we do about that in terms of the data collection? That's kind of open to everybody.
That's a great question.
I'll try to be brief here, but it's getting into the technical side of like supply, demand, modeling, all that sort of stuff. Obviously, it's a necessity of what we have to do. But then at the same time, like, we've been trying to build indicators. Like, we have a port tracker, TEU port tracker, pretty much North America, trying to understand, the Port of New York, New Jersey overtakes Port of LA, looking at the trends, most current information. Is that a new trend? Are things just disrupted and we're going to get back to normal? We're paying close attention to retail sales all the time. What's happening with the consumer across America? What does that mean for the region? Inflation obviously is impacting things. What's the proxy for volume? We're not technically in recession. It's arguable, but, volume's down about 1%. It looks like, how does that, we've got data sources to try to get at that in Southern California, right? So those things aren't perfect. They're not like real time. They're not like what's happening tomorrow, but they're close enough of what the trends are showing, right? You can look at the historical trends and they kind of give you a picture of where we're at in a trough, how we're coming out. We try to build tools and analytics like that to help us gauge a little bit of what does this mean for where we need to be focusing on all these other more complicated areas.
Any others?
Maybe quick.
Sure.
So for the prediction model in the computer science we're talking about, and also data collection, I do want to emphasize part of my course is from statistics. So there are a fairly newly developed methodology that aims to capture the causal relationship between the factors and outcomes. But a lot of times the research efforts are limited to the data availability. I'm just saying like it's great efforts to collect data, like user data, count data, like Andrew's been talking about, and also the infrastructure data. We know there's some infrastructure there, like set up back then, but we don't know like when that infrastructure start there, and then were they still there like 10 years ago or not, or like what year the infrastructure was there, and then what have been changed over time. So I just say like there's a way to measure those relationships and like just show the patterns, but we just a lot of times we are limited to the data available to us. I love to see the data collection, everything.
So you'd like to know,
Prediction.
Essentially what the infrastructure is doing as well.
Eventually, when we have the launching data, we can like kind of model the relationship between factors and outcome over time. Then we will be able to predict along the time trend.
Right.
Yeah.
Right.
So, yeah, love
That's
that.
what we all wish. We're all trying.
Yeah.
Okay, I think we're getting close. We are at time. Holy cow. Sorry. Any last comments before we say thank you? Last questions or comments? I want to really thank our panel. Great observations, great insights. Problems with Caltrans today, but at least we have some ideas about what we have to work on. So thank you very much, and you all should have a pleasant afternoon and evening, and you're all ready to be here at 8 a.m. on a Saturday morning. Right? Thank you, everybody.
Thanks, Jen.
Thank you.
Everyone.